So I drew two molecules here on the board. So so let's do a couple of problems. So for this one first, I want you guys to give me provide the molecular formula for this compound. So let's do that, guys. So I want to make sure that everybody is writing up, guys. And I might call some names from the list to answer the questions. Okay, so please take your notebook and solve the problem at home. Okay, so I'm gonna give you a couple of minutes. Yeah, for now, the first one. So I just submitted a question for you guys to answer how many carbons do we see in the molecule. So please fill out the pooling. So how many carbons do we have in that molecule for on the top left of the screen? So we have, okay, 16 people still to answer, please, okay? Okay, so the answer, so six more people still have an answer, but that's okay. So the answer is the number of carbons is 11, okay? 11 carbons. We have one here, two, three, four, five, 6, 7, 8, 9, 10, and 11. Okay. So let's answer another question here. Some number of hydrogens. We're gonna make a pooling too. So how many hydrogens? Let's see. Come on, 20 more people to answer. Come on, guys. Count the number of hydrogens in the molecule on the top left. All right, so most people got it right. However, there is interesting. So not as many right answers as with the number of carbons. It's slightly more challenging for you guys, especially at the very beginning. So I'm gonna count it with you here. So three hydrogens here, and another three here. That's 6. One here. That's 7. Two here. That's 9. None here. 3 here. 12. 3 here. 15. 2 here. 17. 18. 2 here. 20. 3 here. 23. Okay. So I don't know how you cannot see. So can you guys see where I'm pointing, or should I repeat? Because I can see it on my screen.
I can see.
Yeah, I see the pointer on my screen. Okay, so total of 23 guys. Okay, so quite a few people had a few. So had it run. So make sure once again 3, 5, 6, 8, 11, 14, 16, 17, 20, 23. Okay, so the molecular formula for these compounds will be C11, H23, and O. Okay. So now, anybody had any question in regards to this question? Ruth, did you have a question?
Yes, I do have a question. In case we are given this kind of formula without looking at the structure, and we are asked to draw the structure, are there other possibilities of getting like a different structure, or we have to basically memorize this kind of structure? This is the only way to do it.
There is no, what are you memorizing here? So the only thing you need to be familiar with is the names, right? What's the name of this drawing here, guys? This notation. What's the name of this?
It's
It's a line and angle structure. That is correct. Okay. So let's write this into condensed formula. Because you need to practice that too. So I don't know what you mean by memorizing, because there's really nothing to memorize here. You just gotta learn how to draw the molecules in line and angle or condensed formula. That's it. So condensed formula would be CH3 2. So these two CH3 here, CH right here. Then we have carbon, CH3 2, CH2, CO, NH, CH2, CH3. So this could be, guys, the the condensed structure, condensed formula. You also gotta be familiar with this. So you must be familiar with drawing the molecules in line and angle. I'm gonna write it over here in case you, for those people who don't remember. And you have to be able to draw the molecules in line and angle notation. Yes, I'll do right now. Okay, condensed formula, we have CH32. So this is CH3 here, another one here, CH here, that's here. Next, CH2, oh, which I forgot here. So you guys should have corrected me. Okay, so once again, CH3 and CH3 bonded to a CH, so CH32CH. Then we have CH2 right here. Then we have carbon bonded to so the groups bonded to this carbon are 2CH3, so we put them in parentheses, CH32. Next we have CH2. Next we have CO, that's a carbonyl. Next we have NH. Next we have CH2 and CH3. Okay, so that's a condensed formula. And once again, so Karen, so can we ever write C11H23NO? Okay, so these two different, depends on the question, okay? C11H23NO is the molecular formula. So one of the things that is important, guys, is to understand questions, okay? And you need to answer the question. So can you ever write C11H23NO? Well, yes, if you're asked to give the molecular formula, okay? If you're asked to provide the condensed formula, then you cannot give C11H23NO because that's not a condensed formula, that's a molecular formula. So molecular formula is, a condensed formula is writing the molecule just like this, okay? So one thing that I want you guys to do at home with every practice problem that you do, write the molecules back and forth from line and angle to condensed formula. Exactly as I'm saying here, provide the molecular formula of this compound, provide the condensed formula of this compound, or given this condensed formula, write the line and angle structure. So the question is pretty, as long as you know the names of the notations, then you should be totally fine. It doesn't matter how I ask, because the question is going to be quite clear and straightforward. So if you're given, so if ask the molecular formula, then you gotta know what is exactly the molecular formula. It's the number of atoms of each atom that are composing that molecule. That's a molecular formula. If you're asked for a condensed formula, you gotta write the molecule exactly as it's given here. It's something we did before in class. If you're asked to give the line and angle notation, then you gotta draw the molecule like this with lines, zigzag. Okay. Any other questions? So you guys gotta practice that. Very important. So now I'm gonna ask another question here. So can you write C? You could, but I would like you to get used to do it as I did it right now, okay? Because that's the way you're gonna find in textbooks, most likely, all right? Okay, here is another question. So let's assume that I'm giving you all the valence electrons. So in these molecules, I'm gonna write it over here. All valence electrons are given. Based on that, my question is gonna be, what is the formal charge which I'm gonna pull right now? So the formal charge of that carbon, the options could be 0 minus 1. Gotta answer that question. So I'm sorry. Let me write the question. I want you guys to tell me the formal charge of the carbon atom that is pointing on the screen, okay? What is the formal charge of that carbon? Okay, so how do you guys, so remember, once again, I'm gonna write it over here for those of you who don't remember, the way we do this, we look, carbon is in, how many valence electrons in carbon? How many
4.
valence electrons in carbon? 4 valence electrons, right? So a carbon means that any carbon with 4 valence electrons will be basically formal charge 0, will be neutral, okay? That's the point of this. So we're gonna look into this carbon, and when we look into this carbon over here, we see that how many bonds do we see in this carbon here?
3 bonds.
So number of bonds is 3. Therefore, we are talking about each bond has 2 electrons, right? So 6 electrons divided by 2, because each bond is formed by 2 atoms. That's a total of 3 electrons. So the number of the valence electrons for this carbon that I am pointing out here, the number of is 3. So if I have 3 valence electrons on this carbon, and carbon is supposed to have 4, it means that it's basically lacking 1 electron. Okay, so since the formal charge, I divided by 2, Kevin, because once again, we have this carbon has 3 bonds, right? 1, 2, 3 bonds, right? So 6 electrons, 2 per bond. That's 3 bonds, 6 electrons divided by I'm sorry. Uh, okay. So anyways, guys, how do we call this carbon? Any carbon with a positively charged +1. So 6 electrons divided by 2. All right, 2 bonds. Remember, each bond is formed by 1 electron. So for my charge, I'm gonna say it's a carbocation correctly. Okay. So any carbon with 3 bonds, guys, will be always positively 1 charged. Okay, you can call it either. To me, it could be a Lewis structure because I gave you all the valence electrons on line and angle, both. So 3 bonds. Okay, that's a carbocation positively charged. As I said, this is one of the structures that you will see the most in orgo 1. So everybody must know that every carbon with 3 bonds is formal charge is +1 and is a carbocation. So very quickly, guys, what's the formal charge of this carbon over here? This carbon has 4 bonds, right? So any carbon with 4 bonds, the formal charge is gonna be obviously 0. What about this one over here? So that carbon has 3 bonds, right? So that's 3 electrons, plus these 2 electrons is 5 electrons. So it's supposed to have 4. It has 5, 1 extra electron. So the formal charge of that carbon is going to be obviously -1. So if anybody that is not following, please type on the chat the question. Be happy to address it. These are things that you guys are supposed to know, but we are practicing precisely to make sure that you really understand this, okay? So once again, this carbon has 3 bonds, 1, 2, 3 bonds. That's 3 electrons, right? 6 electrons total divided by 3, by 2 electrons in each bond. That's 3 electrons. Plus 2 here, that's 5. So it's an extra electron negatively charged, -1. And we call this a carbon ion. So remember that too, because you will see that in organic too, plenty of times. What about this oxygen? So let me pull, I'm gonna pull the question. So what's the formal charge of that oxygen, guys? Okay, so we got a lot of people who haven't answered the question. Want to make sure that you guys are on the other side following, so please answer the poll as soon as possible. That's the only way I have to make sure that people are really working with me. Okay, so most people got it right, so that's great news. Once again, in this case, how many bonds in the oxygen? We have 3 bonds, a double bond here and 1 bond here. Once again, 1 bond here, 2 and 3 bonds. So 3 bonds is 3 electrons, plus 2 electrons here is 5. Oxygen is in group 6, so it's 6 electrons in the valence shell. It has 5, so it's lacking 1 electron, so the formal charge of this oxygen is going to be +1, as most people said. Okay, so that's a good thing. What about this nitrogen here? What would be the formal charge of this nitrogen? Let's pull that question again. See if most people following. So what would be the formal charge of that nitrogen? Okay, so still 24 people not answering, guys. Come on. I'm gonna make sure that you guys are paying attention. Everybody must answer the question. Okay, so that's very good. Everybody pretty much is getting it right. So once again, nitrogen, which group is nitrogen? How many valence electrons for nitrogen? You can type it on the chat. How many valence electrons for nitrogen? 5 valence electrons, right? So this one has 4 bonds, so 4 electrons. It's lacking 1 electron, therefore the formal charge, as everybody said, is +1. So that's beautiful. And finally, and this is I want you guys to tell me what's the formal charge, and I apologize for this because the program is assuming that I'm doing something wrong and correcting me. So what is the formal charge of that oxygen there? And I'm gonna pull that question too. Okay, very nice. So looks like most people Also, everybody got it right. So this oxygen has one bond, that's one electron, plus three lone pairs, that's six electrons. So the total is seven electrons in the valence shell of that oxygen. Oxygen is in group six. It's supposed to have six. So if it has seven, obviously it has an extra electron, and therefore its formal charge is minus one. Okay. So this is what I'm expecting you guys to know. Okay. How to draw molecules from this first section. First of all, before we finish this first part, so from here, if I want to give the Lewis structure of this molecule here that I have on top, what should I do? You can type it on the chat. So is that a complete Lewis structure here?
No.
So what should we add? You can type it on the chat to complete the Lewis structure. Valence electrons where? Which atom needs to have valence electrons added lone pairs? So do we need to add any lone pairs on the carbons? Right? No,
Yeah.
because every carbon here has four bonds. And four bonds, every carbon will have four valence electrons, so nothing to add. Remember, we add dots for the number of valence electrons, right? Every carbon has four bonds here, okay? So not need to add any dots on carbons because any carbon with four bonds already has four valence electrons. What about the oxygen? So this oxygen, how many bonds do we see in this oxygen? How many bonds in that oxygen? Two bonds, right? So that's correct. So two bonds, oxygen is in group six. Six valence electrons. I only see two here, so I'm missing four valence electrons. So I'm gonna add two lone pairs. Correct? What about the nitrogen? How many bonds do we see in this nitrogen here? How many bonds in that nitrogen? Three bonds in that nitrogen. That is correct. Nitrogen, it's in group five, so it's supposed to have five valence electrons. Three bonds, three electrons. So we are missing two electrons. That's one lone pair. So apologize for that. So one lone pair. So now we have completed the Lewis structure. Okay. So that's what we learned in the very early lectures. We learned about electronic distribution of atoms, um, line and angle notation, molecular formulas, condensed formulas, formal charges. Okay. So that's going to be something really important for you guys to really know well. Pretty simple stuff, but it's going to help you so much next semester.